Chapter 8, right triangles. Today we're going to cover section 8.4, special right triangles. Your class opener. 1. List any side lengths that form a right triangle. 2. List any side lengths which form an acute triangle. 3. List any side lengths which form an obtuse triangle. And number 4, list any side lengths which form a right triangle where 7 is the length of one of the sides. Your objective today is to determine the lengths of two sides of a 45-45-90 or a 30-60-90 triangle when the length of the third side is known. So today is about shortcuts. Here's what it is. The first theorem, 8.6. If you have a 45-45-90 triangle, so if you have a triangle where you know that this is a 90-degree angle and these other two happen to be 45, it says the hypotenuse is the square root of 2 times as long as a leg. So here's what I sort of notice. If this leg happens to be a length of 1, it's an isosceles triangle, so the other leg is a length of 1. If you do the Pythagorean theorem on this triangle, you'll find that the hypotenuse ends up being the square root of 2. So this is sort of the ratio of the sides. So if the bottom happened to be 5, the left side would be 5, and the hypotenuse would be 5 square roots of 2. So here's a sample problem. Let's find some missing pieces. So it tells us if r is 6, so I'm going to think if r is 6, find t. Well, t, if I go over to here, is just the square root of 2 times larger. So it's just going to be 6 square roots of 2. Number 2, if s is 2 square roots of 5, how big is t? Well, to get from here to t, I just need to multiply by the square root of 2, which is going to give me 2 square roots of 10. Number 3. It says if t is the square root of 6, how big is r? Well, if I'm coming down to the smaller side, I really need to divide by the square root of 2. So what's the square root of 6 divided by the square root of 2? Since they're both under square root, just divide, and you get the square root of 3. Number 4. If t is 10, how big is s? Well, coming to the shorter side, I need to divide. So I need to take 10 and divide by the square root of 2. But I can't leave a square root of 2 in the denominator, so I have to rationalize it. So I multiply top and bottom by the square root of 2. In the top, I get 10 square roots of 2. In the bottom, the square root of 2 times square root of 2 is just plain 2. Then I notice I can reduce between the numbers outside of the square root. 2 goes into 10 5 times, and my final answer is going to be 5 square roots of 2. Theorem 8.7, here's our second shortcut. It's for a 30-60-90 triangle. So looking over here at my figure, if this is my 60, 90, and 30, and in my mind I remember this one as a 30-60-90 triangle is an equilateral triangle that I sort of cut in half. Okay. If that's the case, it says the hypotenuse is twice as long as the shorter leg, and the longer leg is the square root of 3 times as long as the shorter leg. Here's how this one sort of works out, or here's how I remember this one. If I took the large equilateral triangle and called this much 1, well, I know that that's only half of the bottom, so the bottom would really be 2. So all the sides of an equilateral triangle would be the same, so this piece over here would also be 2. Well, if now you do the Pythagorean theorem with the 2 and the 1, you'll find out that this other leg is the square root of 3. So the values that I really care about are these values right here. If the bottom is 1, the hypotenuse is twice as big, and the longer leg is larger by the square root of 3. So let's find some missing values. So it says if Q is 8, and in my mind, whenever I get to one of these problems, I sort of draw in or mentally picture, here's my equilateral triangle because that's going to help me. As soon as I see that, In my mind says if that's 8, this piece right here is double the size, it's 16. And if you go from the shortest side 8 to this longer leg, you multiply by the square root of 3, which is 8 square roots of 3. Let's look at number 6. I'm going to still keep in the fact that it looks like it's an equilateral triangle up there. If n is 20, and I just sort of work my way around. If that's 20, I know the piece going here is half that size. It's 10. And now I know if I go from the shortest side 10 to this longer leg, I just need to multiply it by the square root of 3. So I'm going to get 10 square roots of 3. Number 7, let's check and see what's happening. Now they're telling me that p is 4 square roots of 3. How big is q? Well, if I go to a smaller side, I need to divide. So if I take 4 square roots of 3 and divide it by the square root of 3, I end up with just 4. And now I know if I go from there to n, the size is just twice as big, and it's going to be 8. Number 8, let's see. They tell us that p is 9. Right, well, if I go from 9 to the shorter leg, I need to divide by the square root of 3, which means I need to rationalize. So the top is going to give me 9 square roots of 3. The square root of 3 times the square root of 3 is just a 3. And now I can reduce 3 goes into 9 3 times. And my final answer is going to be 3 square roots of 3. And I know now from here, 3 square roots of 3. When I go to n, it's just twice as big. So if you double 3 square roots of 3, you get 6 square roots of 3. Find the value of x. So here's where I have to look and figure out, first thing, since I see all of these values as x's and I see this 90-degree angle in the corner, I know that this is a square. So squares, the diagonal is going to cut these into being 45-degree angles, and I can just do my shortcut that says if I have a 45, 45, 90 triangle and I go from the hypotenuse to one of these sides, I just need to divide by the square root of 2, which means rationalize the denominator. And I get 8 square roots of 2 over 2, reduce, and you get 4 square roots of 2. Number 10, let's see. I noticed that the entire bottom is 20 if I put it together, which means that this is an equilateral triangle. I also know that this is going to be perpendicular since the bottom two are both 10. So I do know that this is a 30, 60, 90 triangle. And if I go from 10 to the longer leg, all I do is multiply by the square root of 3. So it's 10 square roots of 3. Number 11, trying to find x. The first thing I notice here is I don't have any sides. If I'm looking at this triangle that has x in it, I don't have any side lengths in there. But I could look at this other triangle up here and sort of, if I can get from the 9 square roots of 3 and figure out this side they share in common, I could then figure out x. So in my mind, I'm imagining that I have an equilateral triangle that looks like this. So the first thing I need to do is go from 9 square roots of 3 to this shorter side here, which means I should divide by the square root of 3. 9 square roots of 3 divided by the square root of 3 is going to be 9. Now if I go to this side length here, which is double, it's 18. And now if I look at the 45, 45, 90 triangle, if I go from the hypotenuse to one of the sides, I need to divide by the square root of 2. So I need to figure out 18 divided by the square root of 2, which means I'm going to rationalize it. And I get 18 square roots of 2 over 2, which reduces to 9 square roots of 2. Number 12. A diagonal of a square has length 6. What's the perimeter of the square? draw myself a little picture. So I know it's a square. They tell me the diagonal length is 6. I know that this is a 45, 45, 90 triangle. So if I go from 6, the diagonal, to any of these sides, I just need to divide by the square root of 2. And I'm going to rationalize it. And I get 6 square roots of 2 over 2, which is 3 square roots of 2. So each side is 3 square roots of 2. Well, if I want to find the perimeter, I have 4 of those sides. So if I take 3 square roots of 2 and multiply it by 4, I get that there's 12 square roots of 2 for the perimeter. And your closure. How are you going to try and remember the shortcuts for the special triangles?